10 or.
Yeah, so there's not gonna be when you look at the Moodle, there's not gonna be something at the bottom
Oh,
of
that's
the
what I was
view.
looking for.
Yeah, don't look
Right.
for that. Where I have put it on purpose to be annoying is you go to welcome and syllabus,
Yeah.
and in the resources, then review week and practice final, everything is here.
Gotcha.
So there's the link to the practice final web sheet itself, the review week whiteboard, the recording from Tuesday, and there will be another one of these after tonight.
Sweet.
I made a specific copy of the practice final, so we all would have one to talk about that doesn't change. Because every time you load this, it changes, right? So that one is here as a PDF. So if you want to look at the answer key, if you want to do some more stuff over the weekend, whatever, there's nothing special about it, except that it's the one we're gonna talk about tonight.
Okay.
So there's two things I have put on our whiteboard. We have this long first column, which was Tuesday's review. But we didn't quite get through all of the group work quizzes in Moodle, so there's one more, which is the second column. And then also I just took that one particular practice final and pulled the problems off it. And set up some things to play around with together with that. So that's what we can do today, finish the group work quizzes and just start going through a practice final.
Sure.
I made a note here of what goes on our 3x5 cards, so we'd remember to talk about that. So yes, welcome and syllabus is the section, right, the very top section when you are here. That's where the review stuff is, and the reason I hide it there is because I want you to look at your other resources. Some people are lazy and don't look at this earlier in the term, and if you said, you know, oh, there's all this good stuff, and you haven't looked at it before, I want you to look. So there it is, review week, practice final, that's where all the good stuff is.
Sweet.
Okay, I've opened up all the tabs I think we might need. We have Moodle, we have our whiteboard. I'm gonna put the link to the whiteboard in our chat so that Dusty doesn't have to load up Moodle.
Where's our whiteboard today? Week 6, you said?
No, it's in that review week and practice final.
Oh, it is.
Review week whiteboard is here, see on the screen.
Gotcha. Review week, resources. I bought a mouse and I keep forgetting to use. I keep doing this and I'm like,
We could make more practice final if we want. I don't think we need to, I'll put that at the end. We have both the scientific calculator and the graphing calculator if we need them. If we want to look up anything in the textbook, then we could do that. Everything is all logged in and ready for us.
sweet.
Okay, could you log into the whiteboard, Dusty? Then I'll know we can get started.
Okay. Let's see.
Hi, Kayla. Let me put the whiteboard link in chat again. Okay. I'll pull everyone towards me. Again. Okay. So the middle column of the whiteboard of these three big columns is where we're starting today. This was what we did Tuesday. This is the group work quiz, the last one we didn't get to, and then we'll go through a practice final on the 3rd. So to enter your answers and get credit for doing this, then you're going to go to the quiz on, is it more about exponents? Yes, that one there. Okay, simplify this big thing. On the side, I put some hints. We have 4 letters to move around, A, B, C, and D. You're gonna grab those with your mouse and move them. If we look at the exponents above the letter E in the 2 things we multiply, that will let us disqualify one of our 4 answers. So if we have a P squared times a P third, P cubed, do we add or multiply the 2 and the 3?
We add them.
Add them, so your answer should have a P to the 5th. So over here, grab one of these, whatever one it is. And the disqualified answer put in this blank to say it can't be that, it doesn't have P to the 5th.
Oh.
Just the letter is off on the right, you can't move the
Oh.
individual.
Oh, wait. Can you tell, I'm sorry, let me explain that again, so.
You
the
know,
letters are
I
moving.
saw you trying to grab, you were trying to grab this one here.
Right,
Because
yeah.
it doesn't have P to the 5th, so that's B. So take the B and say choice B doesn't work because of the
Oh.
exponent above P.
Oh, okay.
Okay, now let's look at the Q. If we have a Q to the 4th times a Q squared, what exponent should the Q have?
Q to the 6th.
6, so which does that disqualify?
C.
The same B, right? It doesn't help
Yeah,
us
okay.
more. But it's still a good line of thought, especially if you're taking a multiple choice test like the GED to be able to think through it this way. It's also the type of thinking you might do if you're checking your own work at the end of the test. Before you turn it in, let's just glance at things and make sure everything makes sense. Okay, next one, check the exponent above R. What should it be?
1.
1, just a plain R.
Yeah, that disqualifies C.
And D, right? So we know it has to be A
Oh, yeah.
without really doing anything tricky.
Right.
Is the constants nice also? 3 times 5 is 15?
Yeah.
Yeah, not 8, not negative 15, right? So there's lots of ways to see which one this is.
So if this was an addition problem, would the exponent still be the same?
If it was addition, they're not like terms. You have to have every exponent on the letters all match in order to actually add things.
So I wouldn't, so you never see a problem just like this, but with a plus or a minus?
Probably not, because usually you can't do anything unless they happen to give you P squared Q to the 4th R in both cases.
Oh, okay. Okay. So the answer is A.
Answer is A, yep. Okay, scrolling down a little bit with me. X squared minus 5x minus 36. So somebody multiplied these 4 options, I did FOIL. Is it always true that the last terms, like 12, oops, let me write, 12 times negative 3, oh, that one works, that one is 36. Do they all work, or can we disqualify any answers?
It looks like
Like B works.
they all work.
Almost, one of them doesn't.
C?
D.
D is a positive 36. Right, so that one doesn't work. So I will write it over here, so negative 12 times negative 3 is positive 36, so it's not choice D. Okay, do all the first terms make a positive 1 for the x squared?
Yes.
Yes.
Yeah.
So now we can just say, well, it's not D. Which of A, B, or C have the middle terms add up to -5? If I have 12x and then
C.
minus 3x, that's not going to be -5.
See,
C, 9 minus 4, right? So. Similar thinking to the first one, it often helps to just look and see what works and what doesn't before you do all the math. And part of it is mental fatigue. If you just tried to factor x squared minus 5x minus 36, it just seems to make your brain more tired for a 2-hour test than this little bit of checking by working backwards. So if they let you work backwards, it can be nice. You could just factor x squared minus 5x minus 36. Okay, now they've asked us to factor 6x squared minus x minus 12. So we're gonna put it in the format of ax squared plus bx plus c. And thinking of it that way, what is A, what is B, and what is C? So drag some numbers around. Kayla and Dusty do some dragging also. Don't make Anthony do all your work.
Your name is covering the factor completely box. Thank you. Okay.
Yeah, there is some lag, by the way, so he might have been rude 10 seconds ago.
Um,
I got it down. Anyway.
okay,
Everyone agree with Anthony's choices?
I tried to delay.
6x squared, so A is 6, minus only one copy of x, so B is -1, minus 12. Okay, so that looks good. So which two did you multiply together?
The
A, B, C, which of the letters?
well, 2 times 6 is 12.
But just with the ax squared plus bx plus c, right? The general routine,
Mhm.
not specific to these numbers yet. You want two numbers that multiply to something and then add to something else.
Well. I'm not sure off the top of my.
You remember, Dusty or Kayla? Otherwise, I'll tell you so you don't have to go look it up.
no.
So it has to multiply to AC and add to B.
Oh. I thought you were asking about like actual numbers. I was like,
Ah,
shit, I
no,
called out on the
no,
spot,
okay.
like, I was like, I was just putting the numbers in this where they
So what is the AC in this particular case?
6, so it'd be 6 times -12.
And B is just -1. So two things that multiply to 72-ish, one is positive, one is negative, and their adjacent number is only one apart. Okay. You got it? What are they?
Um,
I could start my list, 1 times 72, 2 times 36, but
right,
factors of 72 that are 1 apart.
Factors of 72 is one. Oh,
Like if it was 20 instead, I could do 4 and 5. Those are only 1 apart and they would multiply to 20.
Um, seven and eight.
Oh, no, 7 and 8 is 56. 8's one of them. 8,
8 and 9.
8 and 9. And which one do I want to make negative?
9.
9, so that when I add them, I get -1 instead of +1. So 8 and -9 multiply to -72 and add to 1. Then we break apart this x term, right, the one with the -1 hiding in front of it, according to that. So 6x squared plus 8x minus 9x minus 12. So I have taken this minus x, whoops, that's really big line. Okay, so I've taken this minus x term and turned it into two things that are equivalent together. Because when I have 8 take away 9, that's -1. Okay, tell me what to write. Now I am doing my factor by grouping. I am sort of unfoiling. I start with these two, and then I do these two. How do I take the first two things and pull out what's in common?
So you do in parentheses,
There'll be some stuff in parentheses.
do 3, and then x in the parentheses.
3x isn't gonna work. I could do 2x to make 6x squared, but there's nothing where 3 times something is 8.
Oh, right.
So I need something else in front. What's the biggest factor I can pull out of both 6 and 8? 2.
4. No, wait.
4 doesn't go into 6. So that makes this a 3. That gets me the 6.
Oh, I had them back.
And then 2x times what is 8x? That's just 2 times 4 is 8. Everyone okay with that first red bar?
Yeah.
Okay, now I'm gonna have something else, and it's going to be 3x plus 4 also. What goes in front of it this time?
Three.
3, ta-da. And then this part and this part come together. And we get a 2x minus 3 times a 3x plus 4. And we're done. Watching your speed slow down with this problem compared to the early one reminds me to remind you, when you're doing a practice final, don't do it by trying all of the problems like it was a real final. And that's not how learning and brains work. So if you were to give me a stack of flashcards and I'm trying to learn some vocabulary from a foreign language, what would I do? I might start with like 4 or 5 and drill myself on those. And when I get pretty good, then I'll add a few more and maybe have a stack of 10. And pretty soon, if I keep doing this, the first 4 are going to get really boring and quick. So then I'll set them aside and maybe put 4 more in. And I'll just sort of push my way through the stack of vocab, never trying to put more than 3 or 4 new things in my brain at a time. But we're giving myself lots of repetition. And practice finals you should do in exactly the same way. Start just with like the first. And when I say 4 problems, I mean like 1, 2A, 2B, and 3A. Whoever made this, I have to mimic them, and they didn't number problems nicely. They did all this A and B garbage. But just do a few problems, right? 2 or 3 or 4, and load up different versions of them, right? Because whenever you change something, then all the numbers change. So
Right.
keep practicing just a few of them. And if you get somewhat good at them, then add in 1 more down the list. And when they get really boring, then stop that one. And so like, kind of like scrolling slowly down the list, just keep focusing on a few at a time. And if there's one that just seems to not be working for your brain, then skip that, include that at the end. Since it's a timed test, if there's something that's just slow.
I know the timed part of it is gonna hurt me the most.
Yeah.
I thought my multiplication tables are very poor, so.
And you can do stuff with the calculator to help you. So we had factors of 72. Right? I'm gonna be slow because this is a website calculator, but you could imagine taking a physical calculator in front of you and going 72 divided by 2. Does that work? Yeah, but that's 2 and 36 aren't next to each other. 3, does that work? Yeah, 4, ooh, we're getting closer. 5, not a factor. 6 times 12, we're still 6 away, not a factor. 8 and 9, yeah, there we go, they're 1 apart. So even if your multiplication tables are rusty, then you have tools. Don't be afraid to use your tools. Okay, we get to do it again. 9x squared minus 64. This one we could do the same way, but there's a shortcut. I'll tell you the name of the shortcut. Can you tell me the formula that goes with the shortcut? They call this one the difference of squares, because it's something squared minus something else squared.
So we would where find the square root of both numbers and then subtract them.
If it was an equal 0, that would be a great strategy. I'm just solving for x with this equation. I move the 64 on the other side, take the square root of both sides, and I'm speeding along, making great progress. But there's not 2 sides to take the square root of. So, okay, this is a shortcut that if you had done a bunch of homework, you would have seen. You can do this exactly the same as before, but the b term is 0. Right? There's no number next to x. But you could do this the way we did the previous problem. But there is a kind of fun shortcut to do. So I'm gonna make that a different color. Okay, the formula that you can memorize if you want, it's optional, is if I have a squared minus b squared, that's going to be a plus b times a minus b. And if you take this side and FOIL it out, you'll see that the inside has a plus AB and the outside has a minus AB, and that's where the middle term cancels out. So if we look at what we have here, then my A is something squared. What times itself is 9x squared?
3.
3 with a
Yeah.
Three x, right?
3x.
3x times 3x is 9x squared.
Right.
So that's this a squared thing here. And then b. The minus sign doesn't count as part of the b, right? It's part of the formula. I just want some positive number that multiply it by itself and I get to 64.
Well, didn't you say B is 0?
That's a different b. That's the b from this formula. There's nothing there, the x. One of the reasons I don't teach the shortcut is everyone writes it the way I just did, and as you just noticed, it's a different use of b. So here it's the second thing that's, a squared minus something else squared. So what times itself is 64? And in your calculator, you can just put square root of 64.
It's 8.
8. So then I just write it out, 3x plus 8. 3x minus 8. Hello, Zoom, so let me put link in chat. Here we go. Okay. So we could do this the long way, the x squared plus bx plus c method, factor by grouping. But I wanted to show you the shortcut at least once. Okay, back to this one. This is why I didn't worry about factor by grouping a moment ago. Let me pull everyone towards me. Okay. So same as before, we have this thing to factor. Now we're back to the factor by grouping. So we have an a times x squared plus bx plus c. What's a, what's b, and what's c? Grab the blue numbers and move them places.
Let me know when I try to wait and let other people do stuff.
You're letting everyone else eat dinner at home. Okay, yeah. No, there's no negatives. This is a nice, easy read them off, right? So we want numbers that multiply to what?
I wanna multiply 9 and 4.
9 times 4, right? The a times the c. So two numbers that multiply to 36.
Yeah.
And add to,
And add the 12.
12. So
So
again, if you're not great at times tables in your head, then you can just use your calculator,
it's,
but this time you saw it.
well, luckily I only remember 6 times 6, 36.
6 times 6 is 36. Yeah, so 6 and 6.
Yeah.
If you didn't see it, everyone has brains that shut down on a test. They could just start trying them. 36 divided by 2, those don't add to 12. Nope, don't add to 12, don't add to 12, not a factor. 6 and 6 add to 12, right? So it doesn't take long to find it if you're having a brain fart. Okay, so we have this 12x term, and we're going to break it apart with 6x and 6x, because that's what the process tells us to do. So 9x squared stays the same. And instead of adding 12x all at once, we do it 6x and 6x, and we still have the plus 4 at the end. So how do we factor by grouping for this one? We have, again, the first two things and the last two things. What would you do, Pasum Suk? What, what comes out in front with 9x² plus 6x?
3. I would like to add 2.
More than a 3.
No, you think it's 6?
No, the 3 is fine as far as a number. But I want something else there.
X.
Yeah.
X, sorry.
This first term will always have an x come out of the front. Because there's always gonna be an x² and an x. It's just how the shape of this process works.
Oh,
So there we go. And then the second term will have something else in front of a 3x plus 2. What goes in front this time?
2, 2x, 2. Yeah.
And then
2.
these parts come together.
3x and 2.
Mhm. There's a shortcut for this one too, if you want to memorize it, where it's the same thing multiplied by itself. But just as before with the previous problem, then if I show you the shortcut, then B means something different, and it tends to clog people's brains. So just know, if you like the shortcut, there is a shortcut for something that's squared. It's gonna look like AX plus B quantity squared. So you could look that up in your textbook if you want, if you like the shortcuts. But this way works too. Okay, now they want you to subtract and then factor the result completely. So the first thing I want somebody with a mouse to do is over here, I put both a plus and a minus before the x and the plain number term. So delete one of those. Is this term going to be overall minus or plus? Or negative 4x minus 4x?
Something need to cancel.
We're just subtracting, so. This isn't the substitution method where we're like plugging things in, yeah. So if I have a minus number and I subtract a positive, that makes it stay minus. How about the constant term? If I have 12 minus a negative 4, does that wind up a positive or a negative number?
Positive.
Positive, yeah. Okay, so now tell me the numbers and I'll write them in. 8 of x² minus 7 of x² is how many x²?
1.
1. If you want to put a 1 in front, you can, but I'll skip it. Negative 4 minus 4 more.
Of x.
8. And then 12 minus a negative 4.
8.
16.
16 or pass, yeah.
Minus and minus is positive, right?
Yeah.
Everyone okay with the subtraction step?
Yeah.
So now they say, let's factor that. A is 1, B is negative 8, C is 16, just reading them off. So I want two numbers that multiply. 1 times 16 is 16, and add to negative 8. You said 4.
Yes.
So 4 and 4 is 16. We're close. Those add to positive 8.
or a negative 4.
Yeah, if I make them
Negative.
both negative, negative times negative is still the positive 16 we want,
Oh, right.
but now they add to a
Sorry, I
negative
was talking
number.
about the negative 8. Yeah.
So then, let me see if I can make this both on the board. I want to break apart this minus 8. So that
2.
we have a minus 4 and a minus 4. Oops, come on. So that will be
2x.
1x²
1x.
minus 4x minus 4x And then plus 16. Am I remembering that right?
Yeah.
116. Yep.
To grouping them.
Yes.
And,
grouping,
and then 2 in front of 2x.
There's no 2x, there's an x squared.
Oh,
It's gonna have an x in front always.
should be 4 x divided by 4.
X
X
minus,
yeah, minus, sorry.
and then there'll be another x minus 4 here, because those parts always match. Is this gonna be plus or a minus?
4. It should be plus
That would make this a plus 4x if I had 4.
minus.
I want this minus. Does that work for the 16? Minus and minus makes plus. Yeah, that works. Okay, so then the two parts in the front come together.
X and 4. Square.
Again, this one has the same thing multiplied by itself. So if you knew the multiply something by itself shortcut, you could have used it. But this is actually pretty quick. Okay, questions about anything we've done so far? Okay, now we get one of these. You all get to cooperate, don't just have Anthony's mouse happen. So, we've done a bunch of these. Gabe drives from San Francisco to Reading. It takes him 2.2 hours. Elsa, the speed demon, drives it slightly faster, only 2 hours. Her speed is 7 miles an hour faster than his. What are their speeds? So your first job is to take the items here and put them in the table. Sorry to hear that, Kayla. Glad you're back. Those little sort of seat mats that fit inside car seats and catch all the throw up, those are so amazing. Okay, help Anthony. I only see his cursor. Move these 4 things around.
I'm not, excuse me. I'm not able to drag anything, so I'm gonna switch to my other computer.
Okay,
That's why I've been just kind of trying to shout things out. Let's see.
if you're stuck on a bad computer, then oh well, but. Okay.
My
so-
laptop's like a touchscreen hybrid tablet, and sometimes it just has a little bit of issues with stuff like this. So I'm gonna get on my desktop.
Oh, okay, the hours are in a distance category. Move them to time. So all the ones you've practiced before, this isn't a good quiz problem design in my mind, because all the homework, you filled in the distance and rate and then divided to find the time. That's what you've been practicing all term, which is why you filled in those first 2 columns by habit. So in this particular case, for some reason, they decided to switch it on you. And they gave you the distance and the time, and then you have to multiply to get to the distance instead of dividing in the other direction. So Gabe's distance is 2.2 times G. And Elsa's distance is 2 times G plus 7. Oh, and I didn't edit my box right. So this should be, how do the distances relate to each other? So we copy and paste error. They are equal. So they both drive the same distance, Sacramento to Reading. So we can just take the two things I wrote in the distance column and set them equal to each other and then solve. So jigsaw puzzle time. I have all the pieces you need, hopefully, unless I messed up, and just rearrange all of the things on the screen. So that we start with 2.2 G equals 2 times quantity G plus 7. And then keep going. And I'm not sure why this 2.2 is like way up there. Again, you're starting with 2.2 times G equals a 2 times a G plus 7. So something like that. Okay, you do the rest. And talk to each other. Kayla, if you're still cleaning things up, maybe you can at least shout at them. Move the 2.2 here, distribute the 2 to the G and 7, things like that.
I cannot move 7, teacher. Yeah, teacher cannot move 7. I don't know why.
Hit reload if it's not working for you.
Right, this one.
If you have 2.2 of G's, and on each side, you're going to take away 2 of them, how many do you have left? There we go. And then to get G by itself, we're gonna divide by 0.2. So the 77 was the red herring, but it's also part of the answer. Because if Gabe's speed is 70, then Elsa is driving at 77.
Oh, so then also should be 77.
It all makes sense?
Yeah.
Okay, next problem. Here's a fraction. What can't equal 0 in a fraction?
The bottom number?
the bottom, so 2x minus 6 can't be 0. And I can solve this just as if that was a normal equal sign rather than a can't be equal sign, right? Add 6 to both sides.
Right.
Divide both sides by 2. So x is not 3. So that's all you have to do for those. They're pretty easy. Often you can just look at it. 2x minus 6, if I plug in x is 2, x is 3, x is 3, that'll make it broken. Right? Okay, zoom in a little. Let's see if we can do some factoring visually. We could factor this with the a times c as something and b, and then we split it apart and do a factor by grouping, but we've done that a bunch today. They want us to simplify this. And maybe we can. Maybe there's some term where we can cancel out x plus 3's top and bottom. If I'm going to do that, that would mean the top factors into something plus x plus 3. What number might go here to make that work?
2.
2. How do you know it's a 2?
Because make a grouping by the first one.
2 plus 3 is 5, and 2 times.
Yeah, and you can see 2x plus a 3x is the 5x, and then for last, 2 times 3 is 6. So, yeah, and then this part cancels, and all that's left is the x plus 2, and we're done. That's how easy that one is. But notice how we started by thinking backwards. Either I can't simplify this, and I just put a box around it right away, or there's gonna be an x plus 3 that cancels. Those are my only options. So if this works, I have to be able to factor the top as something times x plus 3. Because this x had no number in front, then I also didn't put a number in front of that. If it was a different problem with like a 5x, then that would have to be a 5 there and so on. That makes sense?
Yeah.
Okay, similarly, this one is either done or there will be a 2 minus x to cancel out top and bottom. What goes in my question mark now?
2.
2, almost, I'm close. That would make it 4 minus x, 4 minus 2x, but that's like positive, negative, the opposite of what we have. We don't have 4 minus 2x, we have 2x minus 4.
Oh, -2?
-2,
Oh.
yeah, I want everything to be the other sign. I want the 4 to be a -4 and the negative 2x to be a positive 2x. So if I make this negative, it will flip all the signs. Then I'm done, this cancels, and -2 is my answer.
I'm either having brain farts or I'm overthinking it.
Usually
Okay.
overthinking it, and that's the end. So at 7 o'clock, perfect timing. If we go back up to the top, we've done lots of good work today. And after our break, then we'll go through. If you joined late, what I did was I said, the practice final, every time we load the page, it changes. So I printed one to PDF saying, look at the printer friendly version. Print that. Current sheet, portrait, narrow, looks good, next, and then save it as PDF. So that's what I did. And then I stuck it in our Moodle class. So there's no box at the very bottom of Moodle. or review week. Because then you will ignore the syllabus. Instead, I want you to go to the syllabus, so I'm being annoying. And if you go to resources on the side, then there's a whole little thing, review week and practice final. So it's the link to the practice finals, the whiteboard we're using, the particular version of the final that I saved as a PDF and then broke it apart into all the little pieces so we could talk about them. There's also the recording from Tuesday, and I'll put recording from Thursday here also when today is done. And if you are taking the final in Zoom, I've now put the MyOpen Math practice final, which might look, or might not, I have no idea, closer to your online final. So all of that good final stuff is again in the resources part on the side of the welcome and syllabus part, so that I get you to look at your resources. I'm gonna pause the recording. Okay, welcome back. I want to say this is the last review day because it's the review of Thursday of week 10, but we have another one Tuesday for some people. So yeah, anyway. Our big chore isn't to get through all of this because we're not going to do a 2-hour test in 45 minutes. But we want to figure out what goes on our 3x5 cards. So any review we do is great. If you want to, as a group, say, instructor, your job to just show us this real quick as a teacher to put it back in our brains. Or if you want to say, let's all work on this together again. Some of them I've prepped little jigsaw puzzle pieces and hints, like what we did the first half of class. Others I didn't, because I don't have that much time. So we'll see, but we're not going to get through all of this at the pace we've been going, so. Okay, let's look at all the problems. Zoom. So solve a system of equations by graphing. Got a little smaller. So y equals 5x plus 4, y equals -1/4 x plus 25.
So we know with the first one that +4 is the y-intercept, so we can start with putting a point on +4 on the y-axis.
I'm also going to look at the second one and see that its y-intercept is 25. And my little bit of graph paper doesn't have 25 lines. So maybe I'll just count by fours. 4, 8, 12, 16, 20, 24. And one line is going to cross at 4. And the other line is going to cross a little bit above 24. So check both so you know how to scale your things. Does my x-axis have to also count by fours? No, but it will change how steep things look if I don't make them match.
Right.
So I'm gonna go ahead and make those match also. 4, 8, 12, and so on. Okay, y equals 5x plus 4. I could make a rise over run thing, but counting by fours, that's just a little harder to count over 5.
Right, that's how I would usually look at it, is that it would be 5/1.
I think because of the scale issue, I'm just going to plug in 1. Or not 1, plug in 4. And then I'll look up and down this x equals 4 line and see where to make my other red dot. So if I plug in 4, 4 times 5 is 20, plus 4 is 24. So my other red dot is there. So that's not really any slower for me to do a plugging something in than it is to count up, rise, and run and make a little staircase kind of thing. And it works better with the scale we have. Similarly, I need one other green dot. So if I plug in 4 for the second equation. Then. What happens if I put a 4 in there? 4 times -1/4. Well, if I have a quarter of 4, that's 1, so a -1. Plus 25, that's also 24, so they're both gonna cross right there. As it is, I lucked out and found exactly where they cross. If I wasn't so lucky, then I would have to look and see where the lines cross, but. That makes sense?
Yeah, it threw me off a little bit with the scaling being different.
It is.
But-
But sometimes when you have a reasonably big number,
Right.
we're sort of just stuck and it won't fit if we do it by ones. So I liked that it generated a random number that was, in this case, slightly inconvenient, so you can see. Okay, did that teach us anything to put on our 3x5 card?
Only if you need a reminder on. What the slope part of the equation and what the y-intercept part of the equation is.
Okay, y equals mx plus b means. So what that slope intercept form means, right? What the m is, what the b is. So
Slope
if you
intercept.
need that, put it on, and if you don't, do it. Okay, solving a system of equations by an algebraic method of your choice. No guess and check. So when are both of these equations true? I made a jigsaw puzzle for us. First, notice that we can take the top equation, and that's the easiest one to get a letter by itself, because there's a 2 that goes into everything. And if we divide by 2, maybe move the x to the other side, then we'll get x equals blah. Whereas in the second equation, then there's no common factor, because this 2 and this 5 don't play nice together.
Right.
So go ahead and do the green puzzle here. So take 6y equals -2x plus 38. I'm gonna pull you all towards me. And solve that to get x equals blah. We move the 2x to the other side, it becomes positive. If we move the 6y to the other side, it becomes negative. Now we just divide everything by 2. Okay, that was part 1. Part 2, we're gonna take that thing we just found. And in the bottom equation, wherever we see an x, we'll put in -3y plus 19. I'll get you started. 2y, that part doesn't change, equals 5. And now we see the x, we're gonna put the -3y plus 19. Let's get some of this garbage out of the way. There we go. Everyone okay with how we started? Okay, work together, do the rest. Yeah, that's right. You need the -10 still.
There's the 10. Oh, it's over here.
Draw. So now we found the y. We're looking for a coordinate, right? The place where these lines cross is going to be something comma something. And we know that the y is 5.
Right. So now,
So last step is we had this x is -3y plus 19. That's still the simplest way to find x. So plug in the 5 to this thing. You can box it and move them all together, I presume so. No, that's gonna be too much work, just take that. Oh, I see, you were doing it the other side. Okay, no, this is good. Ta-da. So.
oh, I think she grabbed it out of midair, like from.
Okay, so we took the 5, we plugged it in. And we found out what the x is, so now we know that the x is 4. If I can get my mouse to work. There we go. And since this isn't about suspense, there's our solution, right?
Yeah.
Okay, do you want to do another one? This one looks very similar, right? They both have a 38 even, hey. But in this case, it's the bottom equation that's the easiest to isolate something. Because 3 goes into all of those, and that will get the y by itself.
Say that all again.
Okay, so in this one, even though they were very similar shapes,
Right.
it was getting an x in the top that worked out nicest. In this one, it's getting a y in the bottom because all 3 of the constants are multiples of 3. So I can divide by 3 and they all get simpler. And in particular, one of the letters, in this case, the y, won't have any number next to it anymore.
Right. So you can figure out.
So our first step is to stare at it and say, what's the easiest way to get a letter by itself? Okay, I'm gonna move things so the recording can see. Yeah. Then we take that and put it inside the other one. Wherever we see a y, we'll put the 5x minus 2.
For which one? The top one?
Yep, so you'll be starting with a 4, but
Right.
then instead of 4y, you're gonna do 4 times the quantity 5x minus 2. Should have been a 20x somewhere to disappear. We can make it.
There you go.
We also don't have a -8, do we? No, I messed up.
Oh, I'm getting down.
Yeah, in that step, we did a +3x to both sides. And we also did a +8 to both sides. So the 20 became a 23x and the 38 became. Okay, so again, we have an answer and my thing is not working. And the x value this time is what we know first. It's 2 something. So we'll take y equals 5x minus 2. And plug that 2 into it. That's what's gonna happen here. I have a minus, no. I was in a rush when I made this. There we go, I have a minus. That's just a red error, okay. 5 times 2 is 10, minus 2 is 8. So we plugged in the 2 and we found out that if x is 2, then y is going to be 8.
Oh, so that's what was throwing me off. I was like, 5x.
Yeah, I was thinking if I should do a dot for multiplication, but that didn't seem to work right anyway. Pardon me for that. Okay, 3A. Oh wait, let's go back. So we've just done a couple of these, solve for a system of equations. What do we want to put on our 3x5 cards?
Hmm. Oh,
What I gave you was this first, second, third.
honestly, that'd probably be helpful. I think the thing that used to fail me the most when it came to notes was having an example problem. So that way you can actually see how it was done.
So if you wrote out an example problem like 2A or 2B, then you could see how those steps work.
Yeah,
And they're all
well, see, and
gonna be the
that's,
same.
I did this on a couple problems this term was. I would get the x equals an equation,
Mhm.
and then I plug that into the other equation to get my y equals, and then I'm like, okay, we got an x equals and a y equals, I'm good. And then I'll forget to do the third step. To essentially simplify what x equals.
Okay, everyone okay with that? Other things you would want on your 3x5 card?
Give me 18.
Okay, So I'm gonna whiz through a bunch of these.
Okay.
Partly just for review, but these are pretty easy ones compared to what we've done tonight. So mostly your job is just to shout and interrupt me, or type in chat and interrupt me. And let me know what goes on your 3x5 card. So as I am doing this, pay attention to where it would be slower for you. Or where you would get stuck, and then we'll know. Okay, so something squared is something times itself. 5x cubed times 5x cubed. 5 times 5 is 25. If I have x, that's 6 x's. So then I'm done. If you remembered how to distribute this kind of thing, distribute's not quite the right word, but 5 times itself is 25, 3 times 2 is 6. So there is a shortcut, but you don't actually need the shortcut. Questions about that? Something you want to put on a 3x5 card?
Not learned.
So maybe the exponent shortcuts. So. Do. Um, um, this whiteboard.
Are we recording?
I think we're recording. Yeah, we're recording. Okay, where are we at? Exponent. Shortcuts, no. Okay, so remember when we did exponent shortcuts, only a few of them were really helpful. There was this one. And there was this one, right? So. Maybe those go. Oops, by the way, up here. The exponent things of when you multiply, then you're adding them. Or when it's an exponent to an exponent, that's when you multiply it. The other ones were that if they're inside parentheses, you can spread out the exponent to each of them. If they're a fraction, that's subtraction, because that's the opposite of multiplying them, so that's the
yeah, I
opposite
forgot
of
that.
adding them. And if they're together with an exponent, then you apply the exponent to each of them separately, just a different version of the one we saw above.
So that last one, the answer would still come out as a fraction.
Yeah.
Still come out as a,
Well, it depends on whether R or S is bigger. And so if we had x to the 5th over x third, then that's x squared, because 5 minus 3 is 2.
oh, okay.
But if we had instead x cubed over x to the 5th, Now we have 1/x², because the 3 will take away from both. Right, this is 3x's. This is 5x's. So if I cancel out 3 of them, there's gonna be 2 left on the bottom.
Right, for the x squared.
So sometimes it's a fraction, sometimes it's not. Okay, anyway, good things to put on our index cards. Let's keep going. Simplify this, don't leave any negative exponents. Okay, anything to the 0 is 1. Maybe put that on your 3x5 card if you need to. Do-do-do. Whatever it is, it's raised to the 0, it's 1. Okay, keep going. So that I can just get rid of. A negative exponent moves to the bottom. 25 is gonna cancel. X to the 3 and x to the 5, we just did that, so the 3 goes away, and the 5 turns into a 2. So I'm left with a 15 on the top and nothing else. And on the bottom, I have an x²,
Wait, why is the y cubed? Why is the y cubed moved to the bottom?
because it's a -3.
Oh,
And negative means move it from top to bottom or bottom to top.
oh. That part.
And so that looks like something to put on our 3x5 card. So x to the negative, whatever number that is 1/x to the n. Or similarly, 1/x to the -n is x to the n. So a negative exponent flips it from numerator to denominator. There was that pattern we looked at to show how that works. Okay, moving on. Add and simplify, write them in order. I don't want to do that one because we're low on time, and we did one like that earlier today. So let's just stare at that one that we did earlier today. Is there anything from this that you want to put on a 3x5 card? Maybe an example.
Oh, I
problem.
remember, you've done one of these where you've stacked, oh, I see. So like the one I'm looking at 4A, you could just stack it on top of each other and do it just like you did there,
Yeah,
but it's addition as opposed to subtraction.
so why don't I say here, good for example. One thing, a 3x5 card. So, sorry, it's not up over here, but let's make a little note. See. Column 2. So. Okay, moving on. How to multiply with FOIL. Maybe put that on your card if you need to.
Yeah. Those are good.
How to multiply, this is again like FOIL, or just write it out if you don't remember the shortcut. So, and what you write about FOIL depends on whatever helps you. Isn't it an example problem? Is it just the words first, outside, inside, last? Okay, moving on. Simplify. How many x's can I get rid of everything? Well, they all have at least 4 x's, so I can get rid of that. And that 5 would become a 1 and the 6 would become a 2. They all have 3 y's. That's pretty nice, so that just all goes away. And does 3 go into all of that? Sure, so the 36 will become a 12. The 48 will become a 16. And 180 will become a 60.
Cause you're dividing everything.
And I'm
by three.
dividing everything by 3, so I get 12x squared plus 16x minus 60.
I like that.
So not sure what you want to write on your 3x5 card. Maybe an example, who knows? I'll just put here, maybe example. This is basically just using a bunch of the exponent rules all at once. Right. Okay, moving on. The factoring process, we've done that some.
Right.
So 5A. At 2 or 3, I'll just put and. 5A, right, some example of the factor by grouping. If you look at the test, I'm not sure why the author that I have to mimic did it this way. They say factor, they say factor. They say factor. They say factor, and then they say factor by grouping, but you were doing that all along. I would have put the one where they already started for you and have broken the x up to start with. I would have put that first. Right, because you're just starting in the factor by grouping step. So anyway, there's a lot of those problems, but one example problem handles them all. Plug in x equals 11. Do you need something on your card? Maybe. Remember when plugging in values, if it's negative.
So is that where you make the
not
column of X and Y?
No, this is just plug in 11. -5 times
Oh.
11 times 11, right? So that's a calculator problem. The
Yes.
calculator does all the work. If you have Adobe Calculator that you can't just type in -5 times 11 times and so on and keep going, get a real calculator, right? Especially if it's just a phone app, there's free ones that you can type in the whole thing. How do you divide fractions? Flip and multiply.
Could you just cross multiply?
No, because there's no equal sign. Cross multiply is to take a proportion with an equal in the middle. So if I was to do this, you zip through it, 144 x plus 216 over 8 times 24 over 2x plus 3. Well, we know the 8 and the 24 are going to cancel. Can I take this and get a 2x plus 3? Is this 72 times 2? And 72 times 3? Let me check. What is 72 times 3? 72, there we go. 216, So yes, this is actually 72 times 2x plus 3. So then the 2x plus 3's will also cancel. And all I wind up with is 72. Everything else has canceled out.
And 3.
Oh, and a 3. I'm in a rush and my eyes missed it. Come on, click that, go Miro. 7 and a 3 on the other top here. So 72 times 3, we just did that, that was 216. Okay, ta-da. Not sure what you want for your 3x5 card there. Maybe.
No, that one lost me a little bit. Well, usually when you flip fractions, you multiply across the top, but then you
Yeah.
immediately,
But I like to cancel first, right? Just like if I was to have numbers instead of all those complicated expressions. If you gave me 5 times 7 over 3 times 11, and I'm multiplying that by 11 over 5, I don't want to just multiply across. I'm going to get needlessly big numbers. I'm going to cancel my 5s. I'm going to cancel my 11s. And I'm going to get 7/3. Canceling is just reducing early. I don't want to have to reduce the divided by 11 top and bottom after I multiply. That's too much work. It's easier to cancel it before I multiply than reduce it after. So the same thing is happening. I said, whoever designed this problem wants to test that same thinking. If they put a 2x plus 3 on the bottom, there's probably going to be a 2x plus 3 on the top. So can I turn this into something times 2x plus 3? And well, what's half of 144? That was 72. And is it true that 72 would work? 72 times 3 is 216. I don't have that memorized, so I checked it. And then, yeah, whoever designed this did a good job. There's something to cancel. And all I had left was make a different color, that and that to go there. Should I put that as an example problem to have on your card?
sure.
So 8A.
At this rate, I'm just gonna shrink the whole test into a 3x5 part. So if I show up on Thursday with a magnifying glass, then.
I don't
any
like the
questions?
3x5s. There's this already a self adjusting thing where the more you have, the more time you waste flipping through it. I had one term where someone showed up to their test, to the final with 10 practice finals from the random generator. And that was their notes. Okay, if you think you could use, the 30 pieces of paper in a timely manner.
Do they pass?
Yeah, well, because they had done 10 practice finals, right? They barely looked at them, but. Okay, perform the addition and simplify. So remember to brute force, multiply by each other, find the common denominator. This one is missing the a minus 2. If I do it on the bottom, I have to do it on the top. This one is missing the a minus 9 on the bottom. If I do it on the bottom, I have to do it on the top. And then I would get something over a minus 2, a minus 9. You could figure out what that is and then probably some reducing or whatever. On the bottom, they gave you common denominators already. Again, this seems simpler to me than the previous one. Whoever wrote this test in my mind did it out of order. But if you have common denominators, you add the top. Then what makes this one simpler is you can bet that you're gonna have to do some factoring because there'll be some little term to cancel top and bottom, but there probably is in this one too. Maybe not. Carefully simplify. This is that weird one. Remember how, right before break, we all stared at this for quite a while before Anthony figured out to put a minus by the 2. So this is that one. That, just pay attention that if this x is positive and this x is negative, we can swap that. We can make this a
Negative 44.
9x minus 36 and a negative 1 times an 11x minus 44. Take the negative out front to swap which is negative and which is positive.
Well, why do you do a -1 minus 1144? Right, 11x
Because
minus.
that, the negative 1 in front makes when I distribute it, it makes the 11 negative. And it makes the 44 positive, because negative times negative is positive. So if you pull a -1 out front, it flips the signs on them.
Oh, you can't just flip the signs then.
You can't just flip the signs, so that changes it. I'm allowed to change it.
Well, I don't know, that's what you said, so I was like, sweet.
And so I pull a -1 out front to flip them, and now maybe things will look a little nicer. Let's see, this is 9 times x minus 4. This is a -1 times an 11 times an x minus 4. So we get -9/11.
But you can always use a -1 up front to swap. Or for the denominator.
Yeah, I get one negative. It doesn't matter if I put it there or there or there. They're all equivalent as long as I only have one of them.
Okay.
Because a negative divided by a positive is negative.
Negative, right.
Or a positive divided by a negative is negative, or it's just negative with division at it. Again, I'm not sure what you want to do for your cards.
I'll say this is all great, and I'm glad it's being recorded.
What on, yeah, except now my writing isn't working.
It's because it knows that it's 7:55.
Yeah, it knows it's 7:55. We're not gonna finish, but it. Okay, subtract. I'm gonna need a common denominator. I could multiply both sides by y minus 2, but I would bet there's a y minus 2 hiding in there. And if I factor this, it's gonna be y minus 2 times something. And whatever that is, then the easy thing to do is just put that other factor by the y minus 2. And then they will have the same denominator. I just have to figure out what that something is. Because whatever that is, I have to do it on the top to be fair. So it's probably going to be a y minus 2 times a 3y plus something. What else? Okay, consider a quadratic equation. Graph its parabola and then find the intercept, both x-intercepts and the coordinates. So no time to do all this. Go back to the video of when we did this before. Remember, there's a graphing calculator for Desmos. You can practice this, compare it to that, see how you're doing. This is, again, not a hard thing. There were some rules about, I can just stare at this and say it's a positive x squared. So that meant it's shaped like a bowl, not a mountain. It's going to have a y-intercept. If I plug in x is 0 at 3, so that's just a 3. Oops. For x-intercepts, I plug 0 in for y. And that looks familiar. 0 is a bunch of stuff. I have to factor it and find when those x's equal 0. So that's a factoring one. And the coordinates for its vertex, that was you put in for x -b over 2a. So in this case, -4 over 2 times 1. And then you have to plug that in, see what you get. So plug in -2, see what you get. There's your answer there. So some of that we did a lot of practice on the factoring. Some of that we did just 1 or 2 examples, like the vertex. But it is. And again, maybe example for 3x5 card. It's not really. Okay, you know what I'm trying to write. Solve it by factoring. That should have been earlier. We just had to do that to find the x-intercepts above. Solve it by factoring. They're hiding the 0. Remember to put a 0 on the other side.
So those are the ones where you have to put the disclaimer in your answer, right?
No, because there's no denominators. The disclaimers were that we can't have the denominators be zero, and there's no denominators in this. And then we did lots of examples of the ticket type word problem. We did lots of examples of the upside down parabola. Things go up and then they go down. Where is this zero? And remember that quadratic formula lets you solve these quickly. Can you use the quadratic formula here? No, because they say solve it by factoring. So they're not gonna let you take the shortcut and just plug in the quadratic formula. But for the word problem, they let you. And ta-da, thank you for being with me for another 9 minutes. And we whizzed through, we didn't quite get to take good notes for our 3x5 card.
But at least there's Tuesday.
But at least there's Tuesday. Yeah, if you want to bring in 3x5 cards to Tuesday. If you send me photos of them, I will put them up in Moodle for your classmates to look at, or put the photos on the whiteboard. You can edit the whiteboard, so you can take your photos and drag them on and so you can share your ideas if you want.
Okay.
Okay, I'm gonna turn off the recording. We can still talk a little bit.